movement of substance across plasma membrane in living organisms. So this is so-called the hypo-iso-hypertonic. Now, let's say for those who still don't know what is hypo-iso-hyper, okay, I just explain it real quick, real brief. Now remember, in a solution, you have two things. Since Form 2 or Form 1, you learned this before. You have solute and solvent. Solvent is always your water. Solute is the substance you add in water. Can be sugar, can be salt, depending on what solution you want to make. If you want to make salt solution, I put salt, water. Then I put salt solution. If I want to make sugar solution, sugar, water. I want to make Milo powder, water. I want to make shit water, water. So in our chapter 3, solvent will be always water. Okay, unlike chemistry, you have organic solvent is alcohol. No, in this case, our solvent is always water. So, which means if I have a lot of solvent, I will have very little salt. Meaning, if I have 80% water, I will only have 20% salt. Because since you only have two things, if this thing got 20, the other is 80, if this thing 30, the other 70, just minus off for me. Okay? Now, so we just only, so in chapter 3, right? I mean, in this 3.3, right? We mainly only will focus on water. Even though they say here movement of substance, the substance here is mainly focused on water. Therefore, we only talk about osmosis. Because this is how questions will usually ask. They'll put this thing in the middle here, which is called a semi-permeable membrane. So semi-permeable means only let certain substances, like small substances, water. So let's say if I tell you here, I got 20% salt, 40% salt solution. Both they are solution, not just salt. Okay, guys, tell me, where would my water flow to? Okay, I put here A, B. A to B or B to A? Where will water flow to? Yes, this one, we know, we learned this many times. Even in our plants also, we mentioned this a few times already. Right, that's why I say this is basic. It's definitely A to B, right? More water to less water. Less salt means more water. More salt means less water. So you also remember what are these two solutions called, right? Hypotonic, hypertonic. So more salt is always called hyper. That's why the time when we learn the mangrove, the roots, remember the seawater, hypertonic, more salt now, so it's hypertonic. Also, water will always go from hypo to hyper, exactly the same thing. Okay, so therefore we already know what is hypo, what is hyper. Okay, so isotonic is when both sides have equal concentration. Now you can never have both sides hypo. What if one side is hypo, the other side is hyper? So we always compare one. If both sides is the same, you cannot say hypo. It will be something like this, iso. Okay. Now I don't want to fill up here one by one already because definitely not enough time. So we still redo example question here. So the first example here. Draw the water levels after 30 minutes. So this is the exact same example that I just draw for you, right? So we already say water will always go from hypo to hyper, more water to less water, right? Which is, okay, again, I'm going to label here A and B lah. Easier for us to do question. So definitely, once again, A to B, right? 90 to 85. So which means your water, where will be more after 30 minutes? Where will have more water? B, right? A 流去 A, B 嘛 A flow to B 嘛 So it'll be something like that. Okay? Then explain your drawing. Now, when it comes to hypertonic explanation, right? The points, standard one. Number one, what we always need to say is compare first. Who hypo, who hyper. So in this case, I will say solution A. Yeah, I'll just label A lah. I don't have to write 10% salt solution. Is hypotonic towards solution B. Oh, just now, somebody say want to copy back here, right? This one. Sorry, I'm going to get it. Yeah, done. 1, 2, 3, 4, 5. Okay, so come back here. Solution A, hypersonic towards solution B. So that's the first thing. You always compare hyper, or you can say B hyper to A also can. B to A is hyper. Then number 2, you would explain the flow of water. Osmosis, basically say where the water flow. So basically, the water molecules diffuses from solution A to solution B. So flow of water, number 2. Okay. Then number 3 is the condition. Means after flow, what happened? Then we say the water level at solution B increases. Okay. Next. So this level 2 question, a very typical one also. You will have a cell inside a solution. It can be a plant cell, it can be an animal cell. So in this case, it's a red blood cell, it's an animal cell. Now I want to ask you guys one thing. If here they say 20% salt, here they didn't tell me what concentration. So how am I going to know whether this is hypo or hyper compared to my red blood cell? Who can tell me whether is it hypo or hyper? They just give me the salt concentration or they give me the red blood cell concentration. So what should it be? Okay, yes. The answer actually, it has to be hyper. But why? Now, living organism punya cell, right, the salt content actually is very, very, very low. If you want to know the exact one, in human red blood cells, for instance, have only 0.85% of salt. So long as 1% salt is hyper already. So there's small possibility. I got see one question before, only once in my life. Okay, maybe 1 or 2 like that. They give before 0.1% salt. So if it's 0.1, then it's hypo because it's lesser than 0.5. But usually they won't give you less than 1%. Usually they give you more than 1. So most of the time it's definitely hyper one. Okay. Now when it comes to this question, remember, always take outside compared to inside of the cell. Means we always say 20% salt solution hyper towards red blood cell. We will never say red blood cell hypo to the salt solution. Got no meaning one. Okay, we always say solution towards the cell. Can? So same thing. The first point, they asked me, what will happen to my red blood cell after 30 minutes? So I'm going to explain what is going to happen. So same thing, the first point, I would say solution. 20% salt solution is hypertonic towards red blood cell. Okay. Where does the water go? Water go in or out? Water will always go to hyperma, right? Hypo to hyperma. So water molecules will diffuse out of the cell. Oh, just now I forgot to say here by osmosis. Don't forget to say osmosis. And finally, the condition. So now we're going to explain this question already. You know, what happened to your red blood cell? So we already done explaining. So actually, right, I already told you before, every time when they ask you to explain something, you actually can put this at the first point also. Can you put it at the last point also? Can. So long you could answer this part, can already. So what happened now? Your red blood cell, okay, it will shrink, but we cannot use the word shrink. Because if you remember, plant cell and animal cell shrink or expand got a specific term one. What is that term? Okay, Aiden, very good. So what's that term? Your red blood cell, we will say undergoes, yes, crenation. So crenation is the term to describe an animal cell shrink. Understand? Can, so crenate. So if you look here, above here, yeah, so basically you can write here. So this is hypertonic that time, crenation. But if outside I put hypotonic, water will come in. Correct? So hypertonic cell expand call hey. Can you remember? Mo. Yes, lysis. Expand. Then usually it will rupture. It will burst because too much water already. Okay. Then for plant cell, yeah, here, sorry, cannot see. Plant cell become what? So if it's plant cell, right, these two will be the same. Hypotonic, water diffuse. In, this one's in, this one's out. Same thing. Then it will become, yeah, plant cell is turgid. We learned plants that time earlier in Form 5. We always say turgid here lah. Then if water come out from plant cell, it's called, no, not deplasmolysis, it's plasmolysis. Deplasmolysis is when you take this shrink punya cell already, you put back in distilled water, expand back, then only you say deplasmolysis. Means you shrink already, you expand back. Okay. Now once you've done this, right already, now we look at the last example here, page 17. Last example. 5, 4, 3, 2, 1, let's go. Explain the condition of plant cell after being immersed in solution X for 30 minutes. Okay, so first, so this question, they give you the cell, yeah, ask you to explain the condition. Now they give you the condition, ask you to explain this solution. So what happened to my plant cell? Your cell got changed or not? No change. Okay, don't need to see so long. Actually, it's exactly copy and paste the same cell. So yes, so the condition, right? Okay, just now I put the condition at the last point, but you can put it at the first point also. You can say the plant cell. Okay, now I terbalik answer. Plant cell remain the same shape. Then I put my explanation behind also can one. So now only I explain. So same thing, first we compare. So if it remains the same shape, means you got to talk about solution X first. Same, compare the solution first. Definitely now is no change. So it's same. Is isotonic towards plant cell. So see, always take outside compared to inside the cell. So you can even draw this yourself. So actually they put it inside a solution. So the solution is actually iso. Then we talk about the water. Same thing. So just now hypo, water comes in. Hyper, Water goes out, like the previous question. ISO, how do we explain? Remember or not? In and out, some more. Cannot just say in and out, you must say in and out. Okay, Jinxuan, very good, exactly. Okay, Li Ting, almost there, means at the same rate. Okay, before you say osmosis, must go in and out the same. Meaning, if both sides, you can see here, why will we in and out the same? Let's say both sides is equal concentration. Some of you say, oh, water will not move. Also wrong, because water molecules, remember, they are quite far apart. Right? No, like liquid punya particles, you all learn in science last time. Therefore, they can move slightly more freely. So sometimes the water will actually move across to B. So if one move over, then immediately they will return one back. Oops. So one go over, one will come back. Okay, as they show you over here. So we will say water diffuse in and out at the same rate. So you remain the same shape. Okay, so we write here again. Water molecules diffuses in and out of plant cell by osmosis at the same rate. Okay, so the questions that we do are typical osmosis. Those are very simple ones. So the questions you can do now slightly harder a bit one. Okay, we don't do back the same easy one, because easy one I do with you in front already. So come, but you need those knowledge there to do this question. Come, we do 22 and 23 now. Let's go. 22. 2.1 shows two regions P and Q, which are separated by this page 50. Separated by a selectively permeable membrane, semi-permeable membrane. What is the characteristics of selectively permeable membrane? So this one is basically just explain the meaning lah. So just now we already said it, ma. Selectively means only what? Only allow what? 只让一些 certain substances. Yes, certain substances to diffuse across freely. Okay, the next one, easy lah, this one. Which is hypertonic? Who hypertonic? Hyper. So hyper means got more what, less what. Who is hyper? Hypertonic is more solute, less water. Yes, so it's your Q. More solutes. Sucrose is your sugar, less water, as you can see. So Q is your hyper. No silly mistake. One reason. So reason, you either can use the sucrose to explain, you can use the water to explain, or you can write both. So you can say, because it has more water. When water, we always use the word potential. Hey, less. Less water potential. So we don't use the word water concentration. We say water potential. And higher sucrose, or you can say solute concentration. After 20 minutes, an equilibrium is achieved between P and Q. Name the process which occurs. So, equilibrium. We discussed this earlier today, right? So, what is the process that occurs that make both sides equilibrium? Means both sides same. Okay, this one tests a bit on your understanding. It's very simple only actually. So what happened caused both sides to be equal? So Manshai and Jingshan very good, correct already. Others, what do you think? So just now, like for example, one side, you can see one side got more water, one side less. So obviously more will go to less. Then will be equal. What causes that? No, not isotonic. Means 它经过了什么 process to 让两边平等。What process it undergo to become same? It undergoes. So like when both sides was different, then when come like this, 就是 osmosis. Because 一开始 water more over here 水这里water more over here 水这边比较多，这边水比较少 here lesser water. After a certain period of time, the water moves like this ma. So when water moves like this, then both sides same already. So water cause both sides to be same. So it's osmosis. Cannot. Next, explain the change of the plant's condition in 2.2. So they say this plant, right? They say diagram 2.2 condition of plant on the first day and the second day after being planted with mangrove swamp soil. So we learned about this very reason, right? Mangrove swamp soil is salty, correct? 红树的那些泥土. So why will like this? Now, even though you don't know what is mangrove swamp soil, if you see this case, right, you definitely know the water come out already, right? Yes, so water come out. So therefore, the soil is what now? High. Tonic. Okay, why could we say hypo? Hyper 嘛，水出来嘛 ，water always go from hypo to hyper， 多水去少水 ，more to less water 嘛 ，salt always 是 hyper 嘛。Okay, so explain the change of plant's condition. So the same 3 points 也是。Okay, so we're going to say the mangrove swamp soil first is high per tonic. And you always must compare hypertonic to who. Now, you don't just say hypertonic towards the plants, but it's hypertonic towards which part of the plant? Which part, the soil is exposed to which part of the plant? The roots ma. Yes, so you must say towards root cells. Okay, then same with it. Water molecule diffuses out of root cells by osmosis. And lastly, condition. Even though it's 2 marks lah, but we just mentioned it. So obviously you can see the plant 植物怎样枯萎了嘛? So how do we describe this? The plant, in English we say it's wilt. Okay, so before you say wilt, right, you can explain a bit why it will wilt, because all the water in the leaf all come out already. Right, the water all come out ma. Yes, so we will say the cell shrink already. Okay, so this is plant cell. So plant cell shrink, earlier just now we say already, right? Plant cell shrink is called plasmolysis. So we say this because the last point is always talk about the condition. So we can say the plant cells becomes wilted and plant sorry undergoes plasmolysis. Plant become wilted. Right, so let's do another type of question here. So this one, very often they like to ask objective lah, this one, but yeah, we also really we practice here once also lah for paper 2-1. Okay, this one also related to hypertonic. A lot of you actually still don't know how to see this diagram. Now I teach you, after today you must know. So they say here we have solution P and Q. And what they have here is 2 strips of potato. Now bear in mind, sometimes they will use something else, but whether is it potato strip or other kind of strip, you will cut it the same way. Means you will cut the flesh of the potato with skin stick to it. So 它的 potato 的肉跟那个皮粘在一起 like that. Okay, so remember, only the flesh, only 那个肉 can absorb water to expand and shrink. The skin will remain the same. Okay, because skin in plants generally have cuticle, they are waterproof. So if you look at P, now for those who don't know that, okay, or you know also can try to tell me, did this thing expand already or shrink? So did water go in to make it expand already or go out to make it shrink? What does it look like? Can you guys tell me? What do you guys see? What do you guys see? Shrink or expand? Remember how to see or not? 变大还是变小? Okay, so far all the answers I got all correct. So it's actually shrink. Okay, remember I said the skin cannot change. So remember this, imagine this is the skin. Okay, this is the flesh. So you can see the skin, right? Wrap around the flesh like that already. So the flesh used to be like this. So now the flesh, the roll, shrink, and then the skin wrap inwards. So whenever you see the skin push towards the flesh, means the flesh shrink already. Yeah, like how I showed you, shrink already, the skin wrap. Okay, curve into the flesh already. So definitely water comes out, right? So if water comes out, solution P is high. 水出来了，所以它是 high. Always from hypo to hyper. 然后 Q opposite 咯. So Q is whereby you can see the flesh push the skin out. So basically expand only, you push it out. So obviously water comes in already, hypo to hyper, so outside is hypo. Okay, know how to see this already. So state the type of solution. Q, we already done that. So type hypotonic. How solution Q affects the condition of cells in the strip of potato? Solution Q. So, okay. It's basically explaining the same 3 points again also. Okay, since we already say it's hypotonic, right? So therefore, how does it affect the cells? The water, as you point arrow there already. diffuses. Water molecules, you can say, are in solution Q, diffuses into, just follow this lah, cells in potato strips. And then what happened to my cells? Becomes what? Become turgid. Okay, very good. Because this is plant cell ma, right? Potato plant ma. So plant cell become big, turgid. 2分, 2 marks, just nice. Next question. If strips from the solution Q is transferred into solution P, explain what will happen to the cells in the strip after 30 minutes. Okay, Q go to P. So wait. If from the solution Q is transferred to P. Okay. Now what will happen to the cells in the strip after 30 minutes? Okay, so what happened to it? Basically the same as P law. No, it won't return to original shape because this is hyper. So it will become the same condition. Right, Q to P. Q to P law. See carefully, Q to P. Right, I'm taking from Q to P. So Q to P, from expand already, now it will shrink. So it's basically explain what will happen to P. So the same 3 points off. We will say, okay, you write yourself, give you 1 minute. Okay, so basically hypertonic. So who hyper to who? Okay, water diffuse where? Sorry, no battery really. Depend. Water diffuse to where? Then the cells, how? Come. Okay, come. Okay, right, this one. Okay, hypertonic towards the cells in the potato strip, water diffuses out, cell undergoes plasmolysis. So shrink plasmolysis. Okay, okay, next. Now this one also you do yourself lah. So this one very simple. Now look carefully. This is the one that was telling me just now. See, they say red blood cell X put in 3% sodium chloride solution, salt solution. And this one Y, they put in 0.1%. So just now we say the red blood cell got how many percent? 0.85. Right? So 0.1 is less than 0.85. That's why this is actually, you can see the cell already burst rupture. So this is hypo. So this is hyper. So they ask you to explain the difference between the process experienced by the red blood cell X and Y. So first you can talk about the process law they experience, which is of course hemolysis, then rupture, and this one is crenation. Okay, why like that? You explain also the difference. So you explain, so you can say, oh, because the red blood's the 3% sodium is hyper, 0.1 is hypo. So therefore, the water, this one is diffused in, out. This one is water diffused in. So you can see the three things that I compare here is the same 3 points. Look. Next, C. Vinegar. Next question. Now, for this part, food preservation is very important your chapter 3. So there are two methods of preservation you actually in chapter 3 you learn. Number one is use vinegar. Vinegar is a natural preservation that can be used to preserve fruits, vegetables to be kept longer. How the vinegar is effective in preservation of mango. So 你们都有听过腌制 right? In Chinese you say 腌制 pickling fruits. So those fruits that you see in some supermarket, they got sell one are those fruits inside a jar. Then so here actually they put vinegar, you know, they think that very smelly, that one. Smell like sweat, smell like feet. 臭掉死那个. So why the mango put inside the jar, the vinegar, right, can last very long? Why ne? So vinegar do what to make your mango last longer? Okay, vinegar, of course, yeah, kill microorganism, right? But how? That's the main thing you gotta explain. Okay, Xin that one, you say water diffuse out cannot. Okay, remember, okay, now I remind you, vinegar you cannot use hypertonic to explain. So even though in this chapter we are learning hyper, this topic learning hyper, osmosis, but however, vinegar has nothing to do with that. Osmosis, nothing. So they just want you to test, you just want you to know only. So vinegar, yeah, you got to say is acidic condition, right? That's the main thing that kills the microorganism. 它是酸性的. So we know that acid doesn't let most living organisms survive, like bacteria also. So you're going to start by saying vinegar is acidic. And then, so you can say it's acidic. So you can say the vinegar diffuse into the mango. So mango will be like a sponge that can absorb the vinegar into mangoes, causing it to be acidic as well. Then the last point you can say bacteria cannot survive in acidic condition. Understand? So whenever you explain preservation method, you're going to say, how do you kill the bacteria? Because if you kill bacteria, there will be no bacteria rotting, decomposing your food. 没有 bacteria 去腐烂你的食物， then 就可以 keep longer, 守久一点咯。Last question, come on. Last one. Come, let's do page. Okay, last few lah. Okay, not really the last question. 25. Page 55. Question 25. Now, this will be the more common preservation we will see in this chapter, which is using salt. Laudan, garam, pekat. Salt. Okay, we ignore this penjerukan. Okay, we just get the salt here. Penjerukan, I think, is called fermentation. So we're going to focus on salt here. So salt, this one only you can talk about the hypertonic. So like salted fish, also the same thing. So when you see salted fish, salted vegetable, salt and sugar basically is the same law, because salt and sugar both is actually hypertonic. So here they say how the following method is effective in preservation of cabbage. So let me just tell you, first you start off with the same 3 points. Okay, so the larutan garam pekat is the concentrated salt solution. We also say is hypertonic towards, you can say, your cabbage cells. So always try to compare to cells, because water goes in and out of cells. Cells, the one that shrink and expand. Okay, then next one, same thing, the water diffuse where? Own self, right? Don't forget to say osmosis. Out lah. Then your cabbage cell becomes what? So water diffuse where? Okay, then your cells become how? So cabbage is plant ma. So plant means will become plasmolyzed. Yes, very good. Becomes plasmolyzed or undergo plasmolysis. Also correct. However, if you don't write the last point, you won't get full 3 marks, because you're going to talk about how the bacteria dies. Now, let's say here's your cabbage. The water all come out already. So the bacteria that's inside your cabbage will have no water. Then they die. Okay, so you say the bacteria, blue color, the bacteria. So this one must say, even though it's the 4th point already, even though it's like we have 3 points already, but you still must say this. They only will get the full marks. So bacteria will become dehydrated, means 它很口渴, very thirsty, no water, and dies. Die. Goodness. Next, almost already. Okay, very fast. You can finish already one. If you cooperate, then we finish even faster. Okay, come on. Next one, they say, in your opinion, what is the advantage of isotonic drinks towards an individual? So what do you mean by iso? So we know those 100 plus are what Gatorade, Revive, we call it isotonic drink. So we learn in this chapter, isotonic means same concentration. So meaning, right, this 100 plus, right, is isotonic to what? Same concentration with what actually? Is same concentration with your blood. Yeah, your red blood cell, your blood in general. So they say, why we always work out already, exercise already, we need to drink this. So usually, of course, we drink after, not before exercise. So isotonic drink and energy drink is different. Energy drink gives you energy. Isotonic doesn't really give you energy, but it replenishes your body with what? With actually mainly water, salt. Because now, let's say this is isotonic, drink the 100 plus, concentration of salt is same as your blood. So when you exercise that time, you will sweat, you lose water, you lose salt. So right now your blood got lesser concentration than the 100 plus. So therefore, after that, it will slowly replenish. Then it become back normal. That's why you usually drink it during or after exercise. You drink before, usually not, won't work one. So you can say the advantage, it is basically to replenish, you can say mineral salts and fluids in athlete. Explain, right? You can say, which is lost through sweating. That's the second point. Okay, we do two more sub-questions. Okay, show you one graph, and we do one more very similar with this one and done. Okay, next. Okay, look at this graph. So in your hypo-iso hypertonic, you must know how to read this graph. Okay, I believe most of you already know how to, but for those who don't know, usually this comes in objective. So look at here, they give you concentration of sucrose. Again, you have concentration, and you have change in length of cell in plant tissue. So you can see here is your length increase. Here is your length decrease. So by looking at this graph, you got to know actually which concentration here is hypo, iso, and hyper towards my cells. Okay, so guys, let me ask you, this concentration here, if I ask you, okay, I pick one random concentration, 0.2. Is it hypo or hyper towards my plant cell here? 0.2 sucrose, is it hypo or hyper? Everybody come. If I don't have everybody put your answer, cannot go back for this question. Come. Everybody, we have 13 people here, hypo or hyper. Just choose one only. Come on. Wait. Hypo or hyper? Okay, I got 6 more people have answer. Hypo or hyper? Come on. It's so easy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No, 0.2, 蛮帅 0.2 是 hypo 还是 hyper? Hypo or 还是 hypertonic towards my plant cell? 还有一个人还没有回答。Hypo or hyper? Okay, the answer is hypo. Because you can see at 0.2, your length increase ma? Right, see, 0.2, the length increase. Right, increase by 0.15 cm. So if you increase in length means what? Water go in or out. So if you let this become like this, water is go in ma. So hypo to hyper, water 是进来. So which means you can here from 0 all the way to 0.35 like that. To say all is hypo because all this concentration, my length increase. Then you can see from here to here, all decrease, right? So decrease, water come out and become smaller ma. Understand? So one more question I ask you all. From here, can I find isotonic or not? Can I find isotonic? Which concentration is iso? 同样, no change. Where is it? Yes, can, right? What is the concentration of iso? 看到吗? Can see or not? It is your x-intercept. So the graph intercept the x, that is 0.35, meaning you have 0 change. That is iso. Okay? Can Okay, last one. Last one, 1 minute, finish already. I want to do this one. Look at the last page. So this is we go hospital, those drip water 去医院吊水 Based on the statement above, how the dehydration problem faced by ENG can be overcome using saline water. Now, if you don't know, right, when you go hospital to drip this water, it's actually not normal water. You actually drip saline water. We call this saline drip. So saline comes from the word salt. So this salt water that they are dripping in is actually same concentration isotonic as your blood. You have exactly the same concentration, 0.85. gram per 100 ml. Or we can say 0.585% of salt, because 1 gram equals to 1 ml. So 0.85, 0.85%. So they say, how can you overcome dehydration? So first you can say the saline water is isotonic towards the blood plasma. So he says he's dehydrated. Maybe he lost in the jungle for 2 weeks, never drink water. So his blood got no water, no salt, remember. So therefore, you can say the saline water, just like the isotonic drink, same thing, will replenish his fluid and mineral salts, 水跟 salt lost in his blood. What happens if you use normal water? What happens if you use normal water? Normal water is hypotonic. Water got no solute inside, so it's hypo. So you put your red blood cell in the hypo, what will happen? You die. Your blood will hemolyze, rupture. You die. That's why you can't use normal water. Okay. Yeah, so that's why your body can have too much water. You can have too little. You must be iso, the same concentration. So that's it for today. Answers I will post next tomorrow. The other questions, got time, please own self go and finish. Okay, there's a lot of questions here. Go and do lah. All right, so any question? If you don't have any, then we'll end today lah. Bye bye. See you.